Welcome to Algebra 2 Honors. This is Lesson 10, Section 1.6, Part A. We're looking at compound inequalities in this lesson. Today we're looking at compound inequalities. Now we talked about inequalities in the last lesson. That's when something is not equal to, so it's either greater than or less than. Compound. What is a compound sentence in English? Well, if you've had English class, compound means that you put two things together. So a compound noun or a compound subject would be two subjects that are acting together, such as the boy and his dog walk to the store. A compound sentence would be two sentences that are linked together by some form of conjunction, such as and, but, nor, for, yet. With compound inequalities, we have two parts to the inequality, and they are going to be connected by either the word and or the word or. Just like in most compound sentences, that's where you will see most of the conjunctions are either and or. To solve a compound inequality, what you're going to do is you're going to break the inequality into two separate inequalities and solve each part separately. Now, that may not make complete sense right now, but when you see an example, that is going to make complete sense. If the word and is used, that means the solution is going to be what we call the intersection of two solution sets. If you think of an intersection in a street, that's where two streets meet. And so it is the concrete or the pavement that is shared by both streets. So whether you're on one street or the other, you go across that intersection, you're basically on both streets at the same time. That's what is going to be happening here with compound inequalities. They have a shared portion for both inequalities. So here's an example of one. We have 8 is less than 3y minus 7, which is less than or equal to 23. This is compound because we have two inequalities in this one expression. And so what I think is the easiest is to break them into two separate inequalities. Some people prefer just to solve it by not doing that, but I find, especially when you first start out, the number of mistakes that are made trying to do it that way are dramatically more. So at least to start out, I'd like you to break them up into two different inequalities. In the future, you might be able to combine them and just keep them as one and work them out separately. But for right now, we are going to break them apart first. So my first step is to take this 8 is less than 3y minus 7, write it down, and then I'll take the 3y minus 7 and set it to be less than or equal to the 23. So I take both parts and I make them separated. And now I can do what we did yesterday in the last lesson, and that is solve for each inequality. So for this one here, I'm solving for the value of y. So I'm going to add 7 to both sides, giving me 15 is less than 3y. I would be doing the same thing over here. I'm going to be adding 7 to both sides, giving me 3y is less than or equal to 30. Now over here, I'm going to divide both sides by 3. The same is going to be true over on this side. We're going to divide both sides by 3, giving me 5 is less than y on this piece, and y is less than or equal to 10 on that second piece. You'll notice we did basically the same steps in both of these. That's why some people prefer to leave them together. But again, initially I would like you to break them up, and eventually you might be able to leave them together and just solve it. But even now, with me working these out for dozens of years, I still break it up. I find I make fewer mistakes that way. Now, it does say solve and graph the solution. So since this is a compound inequality, this is basically an and situation. What values make both of these inequalities true? So you can kind of think of it as this is one road, this over here is the other road. At what point do they have the intersection of those two roads? What values of y make both of these true? What values of y are less than 5 and also less than or equal to 10? Now this one's fairly simple. You could probably think that through in your head and write down the answer, but we're going to go ahead and do a number line to demonstrate it because they did tell us to graph, and so we are going to graph. So I'm going to start off with my line. And now what I want to do is I am going to put either a dot or a circle at 5. Which one should I use? Well, since it cannot be equal to the value of 5, I would need to put a circle. So I put a circle at the value of 5. Over here I have 10. Do I need to put a dot or a circle at 10? Well, I need to put a dot at the value of 10. And then, since this is an and statement, both of these have to be true at the same time. That means I've got an intersection here in between those two values. So it goes from 5, not including 5, all the way up to the value of 10 and including 10. Now, you know me, I like to double check my answers, so I'll throw a random number out there that's in between those two, such as 6, and see if it works out. If I plug in a 6 for y, I get 18 minus 7. 18 minus 7 is 11. Is 8 less than 11? Yes, it is. Is 11 less than or equal to 23? Yes, it is. So it seems to check out in that area, at least using the value of 6. If you wanted to also test some other values, which I would encourage you to do, such as maybe 4. If I plug in a 4, does it work out? 3 times 4 is 12. 12 minus 7 is 5. Is 8 less than 5? And the answer to that is no. So I've got a stopper. 4 doesn't work. I could also try a value such as 11 on this side. If I plug in 11 here, I get 33 minus 7. That's 26. Is 8 less than 26? Yes. Is 26 less than or equal to 23? The answer to that is no. So it appears as though I have the correct solution. I'm going to give you another one here. We have negative 12 is less than or equal to 4x plus 8, which is less than or equal to 32. I'll give you a moment. I would like you to go ahead and try to work this one out. Make sure you show all your work step by step. I do want you to break it off into 2 pieces, at least for today. We might change that in the future, but right now, break it into 2 pieces first so you're dealing with each individual expression or sentence first, and then come to your final answer. Make sure you also graph the solution. So take a moment and do that. So the first thing you want to do is break it into 2 different pieces. So I have the negative 12 is less than or equal to 4x plus 8, and I have 4x plus 8 is less than or equal to 32. In both cases, I'm going to subtract 8 from both sides. So that's going to give me a negative 20 is less than or equal to 4x on the left here. And that's going to give me 4x is less than or equal to 24 on my right side. Now, if I divide everything by a value of 4 in order to solve for my x, I get negative 5 is less than or equal to x, and x is less than or equal to 6. So I need values that are true for both situations. So I need values of x that are greater than negative 5, greater than or equal to negative 5, and also at the same time less than or equal to a positive 6. So drawing out my number line, I'm going to go ahead and graph a negative 5, graph a 6. I'll put a 0 in between those 2 values. Do I need a circle or a dot at negative 5? I should have a dot at negative 5. Do I have a circle or a dot at 6? I should have a dot at 6. And then all the values in between those 2 is indeed going to be my final answer. I could double check by plugging in a value such as 0 into my original equation. Always use the original. We have negative 12. If I plug in a 0 here, that'd be just 8. So negative 12 is less than 8. That's true. And 8 is less than 32. That's true. I could also double check using values such as negative 10 and maybe a positive 7. They are going to work out. Those kind of checks, feel free to do those in your head as much as possible. to save you some time, they are checks, so I'm not necessarily looking for your work on your checks. Try this one. We have -5 is greater than or equal to 3z minus 2, which is greater than -14. Make sure you graph it at the end. So the first thing I'm going to do is I'm going to break it off into two pieces. So I have the -5 is greater than or equal to 3z minus 2, and 3z minus 2 is greater than -14. I want to get the z's all by themselves, so I'm going to go ahead and add 2 to both sides of both equations. That's going to give me a -3 is greater than or equal to 3z, and 3z is greater than -12. Now I'm going to divide both sides of both inequalities by a value of 3. That gives me -1 is greater than or equal to z, and z is greater than -4. So do I have values that are less than -1 and at the same time greater than -4? And the answer to that is yes. Anything in between those two values is going to work. You do want to be careful because these signs here are switched from what they normally are, but don't let that confuse you. Solve it the same way. You just have to make sure that your thought process is working things out correctly. So we're going to go ahead and draw our number line here. I'm going to put a -4, a -1, and a 0 in on my number line just so I know where pieces are. At the -1, do I need a circle or a dot? I should have a dot. At the -4, do I need a circle or a dot? I should need a circle. So I put a circle at the -4, I put a dot at the -1, and all the values in between those two are going to be a portion of my solution. I can double check that by plugging in something like a -2. We'll go ahead and do that. If I plug in a -2 for my z, I get 3 times -2, which is -6. -6 minus 2 more is a -8. So is -5 greater than -8? Yes, it is. Is -8 greater than -14? Yes, it is. I could choose some values on the other two ends just to double check. I would, again, encourage you to do that on tests and quizzes just to make sure that there isn't a situation where they can continue on. We are going to get to those, so it is a good idea to always check all three portions of your number line, both the portion that works and the portions that do not work. If the compound inequality uses the word or, then we have what is called a union of sets for the solution. A union would be something that's together, but yet there are still individual pieces. Unlike an intersection, where if I'm standing in the center of the intersection, I'm on both streets, a union it's part of the solution, but they're not necessarily together in the same area, but they're both really answers. I'll give you an example here as we work one out. So let's say I have k plus 6 is less than -4, or 3k is greater than or equal to 14. Now this one's already broken up into two pieces, so I don't have to worry about breaking them up into two pieces, but I do need to still solve each one individually. So for this first part here, I'm going to have to subtract 6 from both sides. I don't need to add or subtract anything for that second one. That gives me k is less than -10. And this other one, if I divide both sides by 3, I get k is greater than or equal to 14/3, or if you had as a mixed number of 4 2/3, that would be fine. But again, you can just leave them as improper fractions. Now, are there values that would fit both of these simultaneously? Can I have a value that's less than -10 and at the same time being greater than a positive 14/3? Well, I can't have a value that's less than a negative and greater than a positive value at the same time. No number fits that solution. So this is what we call a union of sets because it's an or. It doesn't have to fit both. It only has to fit one of the two pieces. If I give an example of an or statement that on a true or false question on a test, if it said 2 plus 2 is equal to 5 or 4, you would put true because 2 plus 2 is equal to 4. Therefore, that statement is true. Even though it's not equal to 5, it is equal to 4, which is part of the solution because they use the word or. So here we have a union of sets. When we graph it, what we're going to do is we're going to go ahead and draw our number line. We got to put either a circle or a dot at -10. In this case, it's not equal to, so what do I use? I use a circle. So I have a circle at -10. Over here, it could be equal to 14/3, so I need to put a dot at the 14/3. And all the values that are greater than 14/3 are included. So I'm going to draw my line going to the right there. On this other piece, the values that are less than -10 are also included. So I have a line going from my circle to the left and from my dot to the right. You want to check these just like we did with the other one. So let's pick a number that's less than -10, something like -11. -11, if I use this -11 plus 6 is -5, is -5 less than -4? Yes, it is. So that part checks out. If I use a value in between -10 and 14/3, like 0, if I plug in a 0 here, I get 6 is less than -4. Is 6 less than -4? No. 6 is a positive value, so it's got to be greater than the negative value. So it doesn't check out there, but I do need to check it with the other one. If I plug in a 0 here, I get 0 is greater than 14. Is that true? No, it's not. So it's not true with either one of these, but that's okay because according to our solution, it shouldn't be. Now let's pick a value greater than 14/3. So something like 5. Right? 5 is greater than 14/3. If I plug in a 5 here, I get 5 plus 6, which is 11. Is 11 less than -4? No, it's not. But let's check over here. 3 times 5 is 15. Is 15 greater than or equal to 14? And the answer to that is yes. So it does work with this inequality. So both of those pieces of my solution do work. The part in the middle does not. Try solving this equation. We have 5j is greater than or equal to 15, or -3j is greater than or equal to 21. Now in this particular case, I do have the two equations. I went ahead and rewrote them separately. I do not need to add or subtract anything to either side in this particular case. I can go straight to my division. So over here, I'm going to divide both sides by 5 to give me j is greater than or equal to 3. Over on this side, I got to divide both sides by -3. Red flag, we're dividing by a negative number. What do we learn in the previous lesson? When we're dealing with inequalities and we divide or multiply by a negative, we have to flip the sign around. So when I do this one and I divide by a -3, it becomes j is less than or equal to a -7. Make sure you flip that sign around. This is one of the reasons why I really want you to check your final answers after you've drawn your number line. You will very rapidly catch that kind of mistake by checking your answers. It's going to become very obvious that you did something wrong. That's usually the first thing I look for. Did I forget to flip a sign around? So we have a value at 3 and a value at -7. Both of them could be equal, so that means I'm going to have dots at both. I want j to be greater than 3, so my 3 value is over on this side here. So I'm going to put a dot there at 3 going to the right. And j is less than or equal to -7. So I'm going to put a dot at -7, but draw my line to the left or the negative direction for that one. So that is my solution. If we quickly check, if I use a value of something less than -7, something like -10, if I have -10 times 5, that gives me -50. Is -50 greater than 15? No, it's not. If I try it over on this piece, though, we have -3 times a -10. That gives me a +30. Is 30 greater than 21? Yes, so -10 checks out. If I plug in a value in between these two, something like 0, 0 is greater than 15? No. 0 is greater than 21? No. It doesn't work out, but it shouldn't have according to my number line. Choosing a value greater than 3, something like 4, If I have 4 times 5, that gives me 20. Is 20 greater than 15? Yes, it is. I don't even have to check with the other one since it works out with 1 and it's an or statement. As long as it works with 1, you can stop and go on with the other stuff. Try this one. We have g minus 6 is greater than negative 11, or 2g plus 4 is less than negative 15. So I'm going to break it up into its two pieces. On this first equation, I'm going to have to add 6 to both sides. On the second equation, I'm going to have to subtract 4 from both sides. So what that gives me is g is greater than negative 5 on my left, and 2g is less than negative 19 on my right. I'm done with the one on the left, but I do have one more step with this one on the right. I've got to divide both sides by 2. That gives me g is less than a negative 19 halves, or negative 9.5 if you have a decimal. And now I need to put that on a number line. So drawing out my number line, putting a negative 5, a negative 9.5, and you could use 0 or some other value, but those are the 2 points that I need. This one cannot be equal, so I'm going to put a circle at negative 5. It cannot be equal on this one either, so I'm going to put a circle at negative 19 halves. Now I need to figure out which pieces need to be graphed. So g is less than the negative 19 halves, so that means I'm going more negative on that one. So, and on my circle on the right, I should be going to the right. Those should be circles, not points. Something happened there with my PowerPoint. If we were to check our answers, you plug in something like a negative 10 into the original problem. We have negative 10 minus 6. That gives me negative 16. Is that less than negative 11? No, it is not. But if I plug in a negative 10 here, 2 times negative 10 is negative 20. Negative 20 plus 4 is a negative 16. Is negative 16 less than negative 15? Yes, it is. So it checks out. If I plug in a value in between these two, like negative 6, negative 6 minus 6 is a negative 12. Is that greater than negative 11? No. If I have a negative 6 times 2, that gives me negative 12 plus 4, that gives me negative 8. Is negative 8 less than negative 15? No, it's greater, so it doesn't work in that middle area, but it shouldn't. And then plugging in a value that's greater than negative 5, such as 0. Here I'd have negative 6 is greater than negative 11. That is true. I don't even have to check it with the second one, so it all works out on that. So in today's lesson, what we learned are compound inequalities. I encourage you, at least to start out, to break them into 2 separate inequalities, solve each one individually. Then put them back together on your number line. You are going to have to graph most of these, but it does really help in checking your answers. I do want you to check your answers. You can do that mentally without writing anything down. I'm going to trust you that you're going to check your answers on these. Obviously, if you miss a problem in class, that tells me you did not check your answer, or you used some other value that happened to work, but it normally doesn't work that way. They shouldn't work when you check your answers if you've done something wrong. You also want to make sure that you use circles when you're supposed to use circles, dots when you're supposed to use dots when you're graphing. Make sure that if it's an and statement, it should be what we call a conjunction, where they're coming together, an intersection. So there's only going to be one set of solutions. If it's a union, you could have what we call a disjunction, where they are separated, but they're still both portions of the answers. So with a conjunction of and, you're probably going to have just one solution. With an or statement, you're probably going to have 2. That's not always the case, but that is the case in most situations.